In section 2.5, we learn how to talk about the position of a data entry within a data set. There's two main ways that we're going to focus on. The first one is quartiles. And when you use quartiles, you take your data and divide it into four groups, essentially quarters, and each group will contain 25% of the data. There's three quartiles, Q1, Q2, and Q3 is their notation. And because you've got three borders, you create four sections. So Q1 is known as the first or the lower quartile. About 25% of the data is less than or equal to this number. Q2 is known as the second quartile, but more commonly we call it the median. It's the place where about 50% of the data is less than or equal to that amount. And Q3 is known as the third or upper quartile. About 75% of your data will be less than or equal to your Q3. In order to find out what your quartiles are, you're going to put your data in order, then find the middle of the data set first. So you're finding your Q2 or your median first, and then you're going to find the middle of each half of the data, and that'll be your Q1 and Q3. In example 1, this is data for each year in the US, the waste fuel commuters use due to traffic congestion. The amount in gallons per year of fuel wasted in the 15 largest US urban areas are listed. So we're asked to determine the first, second, and third quartiles and write a sentence that makes a specific observation about this data set. Step 1 is to put your data in order. So my data is now in order, and I'm going to begin finding the median by checking off a value from each end until I locate the center of my data. And as you can see, I do have an exact middle piece of data. So this is going to be my median, also known as my Q2. Then once you've done that, leaving out this piece of data, you're going to find the middle of each half. I'm going to find the middle by, again, kind of checking off one from each end. And I have an exact middle. That is my Q1. Then I go to the second half of the data, do the same process, again, ignoring the middle and checking off one from each end to find the middle. I now have my Q3. So for part B, when it says write a sentence that makes a specific observation about this data set, what we're looking for is that you use the quartile information appropriately. So for instance, one observation we can make is since Q3 equals 30, we know the third quartile means 75% of your data is at or below that amount, because it has 1, 2, 3 full sections of 25% each below it. So we know 75% of the commuters waste 30 gallons per year or less. Okay, if you were to write the statement for Q1, you would say we know 25% of commuters waste 23 gallons or less. And the median, again, that represents the 50% mark for the data. So 50% would be at this amount or less. In this example, it all worked out very nicely where we had exact middles. I'm now going to just change quickly to a smaller data set and show you what to do if things don't work out so nicely. So I just made up another data set and I put it in order for convenience. There are 6 pieces of data here. So when you begin checking off from each end to find the middle, what you notice is you have 2 pieces of data that are in the middle. And when that's the case, your median is always the average of those 2, as we've seen before. So in other words, you would take 20 and 30, add them up, divide by 2, and you're going to get 25. So that is your Q2. Then when I look to each side of the data, again, I leave out this amount. So I'm only looking at 10, 10, and 20 and finding the middle of those, which is 10, and then repeat on the other side, and I have the exact middle there. One last example, if I have 8 pieces of data, when I check off from each end, again, I'm going to have 2 pieces of data in the middle, so I'll find their average, which is still 25, and that is my Q2. I do not include that piece of data when I do my checking in the first half of the data set, so I'm only looking at these 4 values, crossing off one from each end. And again, I get this situation where I've got 2 middle numbers. So we treat that exactly the same way. We would find the middle of those 2 numbers. And if we take 10 and 20 and divide by 2, you'll get 15. So in this particular situation, your Q1 would be 15. And similarly, on the other side of the data, I would find the middle of 30 and 40, giving me a Q3 of 35. So those are all the different possibilities that could happen. The next thing you're going to learn about is the interquartile range, or IQR. The IQR of a data set is a measure of variation that gives the range of the middle portion of data. It's specifically the difference between the third and first quartiles. So remember, the word range we've seen used before to mean the difference between the maximum and the minimum. This is also a range, but instead of going between those values, it's always Q3 and Q1. And IQR is useful because it gives us a formal definition for whether or not a piece of data is an outlier. An outlier is a data entry that's far removed from the other entries in a data set. To identify outliers, you will begin by finding those 2 values, Q3 and Q1. You'll subtract them, giving you the IQR. You'll multiply the IQR by 1.5. So let's do those 3 steps first. So we're supposed to find the IQR for the data set in example 1. And are there any outliers? So if we go back and look at example 1, our Q1 was 23 and our Q3 was 30. So to calculate my IQR, I take Q3, always Q3 first, subtract Q1, I get 30, take away 23, which is 7. The next thing it says to do is again multiply your IQR times 1.5. And when you multiply 7 times 1.5, I believe you get 10.5. Now, here's what you're going to do in steps 4 and 5. I find it's helpful to think about it this way in terms of some fences or some borders. So Q1, let's say, was here at 23, and Q3 is 30. What you're going to do next is you're going to subtract this calculated amount, this 10.5, from the Q1, kind of pushing out this way to establish a new lower border. So again, to calculate this number, I'm going to take my Q1, 23, subtract 10.5, and that gives me a value of 12.5. So I'm going to label this new fence or border wall 12.5. Then on the other side, I'm going to do the same thing, except I want to stretch this border and make it lower, so I subtracted. I want to stretch my Q3 border further out and make it larger. Therefore, it makes sense that to find this border, I would go ahead and take my Q3, which is 30, and add the 10.5. And what we've created here are boundaries for the data set at 12.5 and 40.5. Anything between these numbers is considered not an outlier. It's not an unusual piece of data. If you have any numbers out beyond these fences, so anything lower than 12.5 or higher, I'll squish it over here, higher than 40.5, that would be considered an outlier. So now I'm going to go ahead and go back to my data set and see, do I have any values lower than 12.5? I do. I have 11. So 11 is going to be considered an outlier. My other boundary was located at 40.5. Do I have any pieces of data higher than 40.5? I do not. So in this case, there would be one outlier. So to finish answering the question, we were asked for two things. We were asked to find the IQR and any outliers. So we would report that our IQR was 7, and again, that was gallons per year. Units are always important. And yes, 11, and again, units, gallons per year is an outlier. And again, all that's indicating is that it's in some sense unusual. It's either unusually low or unusually high. And again, outliers will tend to affect the mean of a data set greatly. They have less impact on the median. In addition to the quartiles, there's something called the 5-number summary, which is going to give us a new way to graph and visualize data. So in the 5-number summary, it consists of 5 particular descriptors of your data, and they're listed for you right here. They are the minimum value, the smallest, your Q1, your median, which is also known as your Q2. I have another typo I have to go back and fix. Next is your Q3 and your maximum. And using those 5 numbers, we can create something called a box and whisker plot. The steps for drawing a box and whisker plot are listed here, and we'll go ahead and begin with example 4 and show you how to go through those steps. So example 4 says draw a box and whisker plot that represents the data set in example 1, and what do you observe? So for convenience sake, I'm going to go back and look at my example 1 data. I have my Q1, my Q2, my Q3. All I need to grab in addition to that is the lowest value of 11 and the highest value of 35, and I have my 5-number summary. So again, just to repeat, to do the 5-number summary, you're going to do this process of breaking your data into quartiles. I've written my 5-number summary off to the side, leaving space to work on this number line. This is now step 2 of the box and whisker process. We're going to construct a horizontal scale, just on a number line, that spans the range of the data. So you want to set up regular tick marks that count off by the same amount so that it will fit your data, going from at least 11 to 35. And you try to choose numbers that are, convenient to count off by. So in this particular case, I'm going to start counting at 5, 10, 15, 20, 40. Now, there's no real right way to count off or how many tick marks do you need to use. You just want to make sure that you're not making a super tiny graph. Next, after you have your scale, you plot the 5 numbers above the horizontal scale. And we usually do the middle 3 first because they will form the box. So I find approximately 23, and it will be an approximation. It's a little over halfway. And I draw a vertical line above the number line. Again, not on the number line, above the number line. Then I have a median of 25. I again draw a vertical line at that location of the same size. And for Q3, it's 30. I draw a vertical line at 30 of roughly the same size. You need to connect those up horizontally, and this forms what is known as the box of the box and whisker plot. So that accomplishes step 4. And then the reason this is called a box and whisker plot is we add whiskers on the side of the box that stretch out to the minimum and the maximum. The minimum occurs at 11, so I'm going to put a shorter vertical line at roughly 11, and I'm going to connect it back to the box. I'm going to put a short vertical line at 35, and I'm going to connect that back to the box. And that is my box and whisker plot. Now, usually we will label these numbers either above or below the box plot. The 11, the 23, the 25, 30, and 35. So that way we don't lose the exact data, because again, when we plotted it, it was an approximation. So to make it very clear, we go ahead and put the labels on it. Very often you'll see the box shaded, but you don't want to lose sight of that median. So be careful with your shading, don't obscure that. We also should be putting a title on this. This is a nice graph because, again, you get a sense of the whole range of the data. And in addition, because these are quartiles, because we have divided the data up into 4 sections, I know that I have 25% of my data in each section. So 25% of my data is between 11 and 23. I have another 25% in the first section of the box. So between 23 and 25, I have just as much data as I do from 11 to 23. We have a lot of values in a small area versus the same number of values over a larger range. I also have 25% of data in the second part of the box from 25 to 30, and 25% of the data is here from 30 to 35. So again, this allows us to say things like, oh, okay, so then if I look here, I know 50% of my data is equal to 25 gallons or less. And we can do other sorts of observations as well. I am going to post a video of how to make a box and whisker using Excel as well. It's a pretty simple process there too.